Hi, welcome to Wise Guys. This session is about the empirical formula of a compound. First, let's see what is empirical formula. Empirical formula shows the ratio of the number of moles, shows the ratio about number of moles of elements denoted by the subscript. So for example, we have a formula is glucose is C6H12O6. From the subscript, this is a 6, 12, 6. The ratio of the number of moles element is C to H to O, carbon to hydrogen to oxygen equal 6 to 12 to 6. The simplest ratio, we talk about this ratio, is talking about in empirical is 1 to 2 to 6 to 1. Because 6, 12, 6, we divided 6 for each of them. We got 1 to 2 to 1. That's why the ratio in empirical formula of carbon to hydrogen to oxygen is 1 to 2 to 1. That's why, because 1 to 2 to 1 is the simplest ratio of 6 to 12 to 6. That's why sometimes we call empirical formula as simplest formula. So in this case, the glucose C6H12O6, the simplest or the empirical formula is CH2O, because 1 we don't need to write 1. H2O. To looking for the empirical formula, we are given the percentage composition of this compound. So from the percentage composition of compound, then we can find the mass of each element in 100 grams. Let's look at this example. To find the empirical formula of compound that has the following percentage composition. Carbon 80.87% means in 100 grams of this compound, there are 80.87 grams of carbon. This is in 100, right? In 100 grams of this compound, you have 80.87 grams of carbon, and hydrogen, you have 11.70 grams hydrogen, and also you have 7.43 grams of oxygen. So this is in 100 grams, because this is from percentage composition. This is the easiest we find in 100. Because the reason is, if you have 200 and this compound is just double it, right? Double this one, double that. If it's 300 grams of this compound, it's triple each number. Because we don't know the molar mass for this compound. That's why we want to know the ratio. So that's why we put in 100 grams the mass of each element. And the second step, it says you need to convert the gram to moles for each element. And after find, because we know this is carbon, this is hydrogen, this is oxygen, we know the molar mass for carbon is 12.8 1.01 gram per mole. Hydrogen is 1.008 gram per mole. Oxygen is 16.00 gram per mole. And we can find you have 80.87 grams of carbon and how many moles. That's why this is the second step, convert the gram to mole for each element. Then we can find the ratio of moles for each element. And later on, we can find the empirical formula. I set a table, let's say this one. Set the table, we put this number into the table. The empirical formula of compound, we write carbon is X, have X mole of carbon, and Y moles of hydrogen, and Z moles of oxygen. So the percentage composition which is given is this is we put here 80.87 gram percent. This is 11.70 percent. This one is 7.43 percent. In 100 grams we have 80.87 grams, and hydrogen we have 11.70 grams. Oxygen is 7.43 grams. The atomic mass, which is molar mass, and unit is a gram per mole. Carbon is 12.01. Hydrogen is 1.008. And oxygen is 16.00 gram per mole. Next, we're looking for the number of moles in 80.87 gram. How many moles for this? We calculate divided 80.87 by 12.01. We divided this number grams by gram per mole, right? Divide this one by gram per mole. Divide the 7.43 gram by 16 gram per mole. And after calculate, and we can find the number of moles, and we can use calculate to find the answer. 80.87 divided 12.01, you got the 6.7, which is not a whole number, but if it is not whole number, it doesn't matter. Later we will figure out. So we first just divided these two. We got 6.734. This is the moles, number of moles. And this one, 11.70 divided by 1.008, we got 11.61. 11.61 mole. And this one is 7.43 gram in 100 grams. Now each mole is 16 grams. So we divide the 7.43 by 16. You got 0.4640. This is 44 mole. As we know, the number of moles, now you have decimal, all decimal. So that's why we need to find the mole ratio. As we know, the empirical formula is the simplest formula, which shows the simplest ratio of each element in moles. So how can we make the ratio? Because if you write the ratio in number of moles, it says 6.734 to to 11.61 to 0.4644. So if we assume this one is 1, that's why we divided this one, each of these moles, by the smallest number, 0.4644, divided 0.4644, 0.4644. This is also moles, right? This is moles, this is the moles, and this is the moles, okay? Then we got, this is the ratio, that's why mole ratio, and this is equal to 1, right? Different color, and this is equal to 1 because 0.4664644 divided 0.4644. If this is 1, what about this one? 11.61 divided 0.4644, almost we got 25. You can use calculator to find this one. And this is ratio 6.734 divided 0.4644, we got 14.5. This mole ratio is 14.5 to 24 to 1. But this is still not simplified because this one is with decimal. That's why we want to get the whole number mole ratio just by multiplying by 2. This is 14.5 multiplied by 2 make whole number. So multiply by 2 this one, you got 29. Multiply 2 for that one, we got the 50. Multiply 2 this one, you got 2. And the whole number ratio of carbon to hydrogen to oxygen is 29 to 50 to 2. This is the empirical formula. So that's why this is the x equals 29, y equals 50, and the z equals 2. That's what the simplest form of this compound is C29, H50, and oxygen is 2. So in short, I give you total, the steps is from the given percentage composition to find the mass in 100 grams and divided the molar mass of each element. You got number of moles, and after get the number of moles, remember you need to divide it the smallest number of moles to make a ratio. This is 1. So if this is 1 and this is 25, this is 14.5. Sometimes you just get whole number. Sometimes if you got this one is 24.9, just round up to 25, right? But this case, I just show you something is not, you cannot round it at 14.5, you cannot round into 15 because 14.5 is still a big difference with 14.999. So that's why this one you need to leave this one by multiply by 2, make 29, then this is 50, this is 2. Then the empirical formula of this compound is C29, H50, and O2. So this is a video presented by Weinstein. Thank you very much. Have a nice day.